Picture a flawless network, dozens of highly specialized AI agents working together, passing data to complete a complex enterprise objective without human intervention. For years, engineers built these systems by handwriting bespoke point-to-point integrations. Every time a new agent was added, a new custom bridge had to be constructed. Maintaining that web of connections quickly turned into a spaghetti code nightmare. The operational friction of keeping these bots talking to one another easily erased the productivity gains the AI was supposed to deliver. Building a true digital workforce requires standardized architectural foundations. Imran Ahmad points this out clearly in his book, 30 Agents Every AI Engineer Must Build, which you can grab right now on Amazon and Pact. Without a universal framework in place, bolting more agents onto an enterprise network only scales its complexity and fragility. It doesn't scale its capability. To fix this, disparate agents operating across entirely siloed systems needed a common language to discover and communicate with each other. Google, along with over 50 major technology partners, including Atlassian, Box, and Workday, recently launched the Agent-to-Agent Protocol, or A2A. A2A is an open protocol designed specifically for peer-to-peer collaboration. By leaning on existing web standards like HTTP and JSON RPC, it ensures that these interactions meet enterprise security and integration requirements right out of the box. A2A aims to replace hard-coded interactions with a system where agents can recognize one another's abilities, allowing developers to focus on task logic rather than the mechanics of the connection. To see how this works in practice, we used the architectural matrix. This model divides agent frameworks into two axes, a horizontal axis connecting outward to peer agents, and a vertical axis connecting downward to raw data sources. This diagram illustrates the horizontal axis, showing how A2A governs peer-to-peer coordination. We see a circular routing of messages between Agent 1, Agent 2, Agent 3, and Agent N in a decentralized system. Look closely at the labeled envelopes moving between them. The protocol defines specific structured packets for these interactions: state for contextual data, role for responsibilities, task for assigning work, and status for progress updates. Now look at this chart representing the vertical axis. Here, the Model Context Protocol, or MCP, handles how a single agent connects downward through a universal interface layer to access non-agent tools, APIs, and data sources. We are producing an entire video dedicated exclusively to deep diving into MCP right here on the Neurals_CA channel, so make sure you hit subscribe so you don't miss it. A2A and MCP are complementary systems. A2A builds your horizontal communication network, while MCP equips your agents with a vertical tool belt. Let's apply this matrix to a concrete enterprise workflow, like a hiring manager requesting the system to source a new software engineer. This diagram maps the process. At the top, a user submits a request to an interface agent, labeled Agent A. Agent A searches the network for a specialized peer. Following the flow downward, Agent A securely hands off task parameters to Agent B, the sourcing agent. Once Agent B finds a candidate, A2A passes that artifact to Agent C, the background check agent. At the bottom, we see they maintain synchronization by pulling from the shared state database. By standardizing task lifecycle management, A2A allows specialized agents built by completely different vendors to form dynamic supply chains on the fly, collaborating to complete long-running tasks. A2A standardizes capability discovery and user experience negotiation across the board. It directly solves the maintenance friction that previously stalled out ambitious multi-agent initiatives. Standardizing how these agents negotiate tasks means an organization can swap out a research bot or an accounting specialist without rewriting its entire system. If you want to see how the other half of this matrix works, remember to subscribe so you catch our upcoming vertical architecture deep dive on the Model Context Protocol. And if you're a developer ready to stop theorizing and start building these exact frameworks today, pick up Imran Ahmed's 30 Agents Every AI Engineer Must Build. Layer is solved. Head over to Neurals.ca for the source diagrams, code repositories, and further resources. Thanks for watching.